Welcome back to the most exciting review this side of the Mississippi. We've come to number 12, and there are multiple ways we can do this. So we got 2x to the fourth, y to the second. That's all raised to the third power. And then in the denominator, we have the same thing, just not raised to any power, raised to the first. So you could recognize that that just is going to make, if all of this is raised to the first, they have the same base, and we could really just write 2x to the fourth, y to the second, and that's all going to be squared, which would give us 4x to the eighth, y to the fourth. And that's only as good as it is if you see it. I'm going to go out on a limb and say most people wouldn't see and recognize that immediately. So what can we do instead? Well, we can do all of these things to the third power. That's going to give us 2 to the third power, x to the, how do we combine those? That's 12, y to the, we multiply these and we get 6. All of that over 2x to the fourth, y to the second. And you'll see that this is a little more time consuming, but really not bad. So we've got 2 to the third, which is 8 divided by 2. That gives us 4. We got x to the 12th over x to the fourth. We just do 12 minus 4, and that gives us x to the 8th. And then y to the 6th over y squared. 6 minus 2 is 4. So we get the same answer. It takes a little bit longer, but you can only do what you can see. So there's that. Next up, we're moving into some rational expressions, which should look a whole lot like what we just did. But we had some new techniques and things that we did for these. So I'll show those as we go along. We've got 4x to the third over 14x squared. So the quotient rule that we just used in the previous examples comes into play here, where you've got 3 minus 2 is x to the first. And I think that's the easiest way to simplify that. And then you got the 4 divided by 14. That just simplifies to 2 over 7. So that's the answer there. We do want to be careful or weary of excluded values. So those would be things that we plug in for x that simply don't work. The reason they don't work is because they cause the function to become undefined. So if I am going to, if I look at my answer, if I plug in a 0 right there, that's 2 times 0 divided by 7, that's 0 over 7, and that's not a problem, that's just 0. But if I look at the original, and remember, that's the whole thing here, is that we're saying that what we've put in that box is the same as this expression, that they're the same. But if I put a 0 in for x on the original expression, this would become 0 divided by 0, which is undefined. It's a huge no-no in the math world. Can't divide by 0. And so we would say that's your expression, but also just be careful, x can't be 0. And now it's your expression, and it's equivalent to the old one. If you must avoid this piece of education, you can, but I am going to put this in the calculator because I think it's important. And if you're still here and you haven't scooted ahead, props. So there's our original, and let's see, 2x divided by 7. Here's our simplified version. You see that they're the exact same line, except at one point. See, when x is 0, the original gave us an error, and our new version doesn't give us an error. And so basically we're putting the error back in there. We're saying, hey, this is an error. Don't do this. That would be a mistake. But everything else is equivalent. They're all the same. Good stuff. 16, 18, 20. Let's do these. Okay, we got some more expressions to simplify. We're not trying to solve anything here. We are just trying to simplify a complicated expression and make it less complicated. Okay, so how do we do that? Well, generally we do that by factoring. How do we simplify 14 over 10? Well, we recognize that 14 is just 7 times 2, and 10 is 5 times 2. we know that 2 divided by 2 is 1. And so that original fraction is just 7/5. That's how we simplify fractions. Well, we can do the same thing with expressions, but the factoring part is a little bit more difficult. So we need to do a times c. A is just 1. So a times c gives us 28. We want factors of 28 that add up to the middle number, -11. Hopefully you recognize they both need to be negative, because a negative times a negative will make a positive, and a negative plus a negative will make -11. And that's -7, -4. So this becomes m minus 7 times m minus 4 divided by, well, what do we do with here? With the denominator? We do a times c? No, because there is no x squared term or m squared term. This is an easier one to factor. We just do a greatest common factor. What can they both divide by? 5. And if we divide them both by 5, then that would give us 5 times m makes 5m, and 5 times -7 makes -35. And what do we have here? We have m minus 7s that divide out. Leaves us with m minus 4 over 5 as our final solution. And m cannot be what? Remember, it's the denominator of the original. So anything that would make that denominator be 0 is no go. In that case, m cannot be 7. 18, very similar, just got 2 quadratics this time instead of 1. They both have leading coefficients of 1 though, so that's very nice of me. It's -36 that add up to -5. Take a quick pause, think about it. -9 and 4, that's p minus 9, p plus 4, divided by, let's do this one in blue. So we need factors of -8 that add up to +2, 4 and -2. So for p plus 4, p minus 2, and your p plus 4s cancel out, divide out, they leave us p minus 9 over p minus 2. P's don't divide out here because you have to take the whole term. You can't just divide p by p. P is supposed to also be divided by this -2. So you can't just do part of that. You got to do the whole thing. So that's the simplified version. What can p not be? What are my excluded values? Hopefully you're looking at that and you say 2, but there's another one. This one that we crossed out also gives us one at -4. So that's that one. And the last one, we'll do a quick number 20 here. Number 20, we'll go with this little. Adding these things, you're still going to have you're still going to have excluded values. So when we add these up, we're going to have a denominator that can't be 0. And if x is 0, then 16 times 0 to the 3rd power is still 0. That would be a no-no. So that can't, the denominator can't be 0. But what do we do with the numerator? Well, when the denominators are the same, we're just adding. So we're doing this part. X plus 3y plus x minus y. X plus x is 2x. 3y minus y is 2y. All of that over 16x cubed. And can we simplify this anymore? Can we divide the x's out? What can we do? Well, in the numerator, do we have any common factors? Yep, 2. So we can divide both those things by 2 and show that if we want to get back to this part, we just have to do 2 times x and then 2 times y. All that's divided by 16x cubed. And now that we've got the entire factor of 2 and 16, we can make that 1 over 8. So this becomes x plus y over 8x cubed. And x can't be 0. That's that. we'll get back at it in another video.